You guys are going to watch a video about conditional probability. And at the end of this video, if you feel like you need a little bit more assistance, I will post some more videos on YouTube. From YouTube on my big campus. There isn't anything from Study Nova. I don't know why they don't go into probability, but it's okay. Hopefully you'll understand the idea behind conditional probability. But if you need help, I'll post some extra stuff. So conditional probability is a little bit different from the probability that we've been dealing with, being that it is when one outcome is dependent on another, meaning that no longer are we looking at one particular outcome out of the whole. Now we're looking at one particular outcome in a certain set within the whole, okay? And the best way I want to explain this is by taking the archery example. Let's say we want to find if the probability that a student chosen at random does archery given that they do badminton. That is an example of conditional probability, because I'm not looking at, if a student is chosen at random, if they do archery out of the whole group. I'm looking for the probability that a student does archery given that they also do badminton. So if we recall that example, remember we had our universal set. There were 100 students total. There were 48 that played none. I think there were 16 that did both, 22 that did just archery, and 14 that did just badminton. I think that was the example that we used from the other day. So we're actually going to use this to show how we would actually find the probability that a student chosen at random does archery, given that they do badminton as well. Okay? And the notation of representing conditional probability is right here. The probability that A, this bar, B. Now this bar is usually represented by the word given in the problem, but it doesn't always have to be given. Usually that's the key word, but sometimes it'll say if you have this situation, then what's the probability? So you just gotta watch the wording so you know if it's conditional probability or not. In general, for two events, A and B, the probability of A occurring given that B has occurred can be found by using this formula, and this is the formula for conditional probability. Okay, it's the probability of A intersection B divided by the probability of B. Now what you have to realize is that whatever the given is, that always goes second in the formula for conditional probability. It is also the probability at the bottom, just whatever is given. Okay? Now in your reference booklet, you might see something around the lines of the probability of A given B times the probability of B equals the probability of A intersection B. I believe this is what's in your reference book, but do realize is that these two are the same thing, okay? It's just written differently. Most of the time you're looking for the given, the probability given, probability of something given something else, and so you use the top equation, but I don't want you to be thrown off by the one down at the bottom, okay? So if we look at the example, it's about the archery, is asking what's the probability that a student chosen at random does archery given that they do badminton. So I will set it up. I'm going to use the very first equation. The probability that they do archery given that they do badminton. Badminton. Don't judge me on my spelling. That's why it's not English. So you're going to basically look for the probability of the intersection, the kids who play archery and badminton. And you're going to divide it by the probability of the kids who did play badminton. Okay? So you go and you look at your Venn diagram. You're looking for the intersection of archery and probability. Well, that was right in here. That was the 16. So at the top, it's going to be 16, all right, out of the total 100 kids, divided by the probability that they played badminton. Well, that was given to us as the probability of the kids who played badminton was right here, which was 30 out of 100. So you basically have one fraction on top of another fraction, and then you just simplify. Remember, when you have a fraction divided by another fraction, you keep, change, and flip, and then you simplify. As you see, your hundreds will cancel out, and usually this is what happens. They'll cancel out. And so your final answer is 16 out of 30. So the probability that a student chosen at random does archery, given that they also do badminton, is 16 out of 30. Now, yes, you probably could have just looked at the Venn diagram and saw that, okay, well, I just need to look at that part in the Venn diagram and get the answer. That's fine, you can do that. But for the situations where you can't create a Venn diagram, you want to use this formula here. So let's look at an example. It says, the 52 staff at school, 36 drink tea, 18 drink coffee, and 10 drink neither tea nor coffee. So we're going to answer these questions here, and we're going to figure this all out. Okay? So it says, how many staff drink both the tea and coffee? Well, let's draw a Venn diagram. Let's just to figure this out. Okay? So we need our universal set. I need a bubble for tea, and I need a bubble for coffee. Okay? It says the 36 drink tea, 18 drink coffee, and 10 drink neither. So we already know that 10 goes in that open spot. Now we don't know how many drink both. So we're going to label that X, and then those who drink tea is going to be 36 minus X, and those who drink just coffee is going to be 18 minus X. Now if you recall from the other day, to find out X, we just add up all these parts and set them equal to the total, which was 52. And then we saw 36 plus 18 plus 10. That all adds up to be what? That's right, 64. Negative X, X, and negative X gives me negative X equals 52. When I subtract 64, I get a negative, I get a negative 12. And so X equals 12. So there are 12 people who drink both coffee and tea. Which means that there are 6 who drink just coffee, and then there are 24 who drink tea. And if we check, 24 plus 12 plus 6 plus 10 does add up to be 52. So, how many staff drink both tea and coffee? Well, that is 12 out of the 52 people who drink tea and coffee. It says one member of the staff is chosen at random. Find the probability that he drinks tea but not coffee. Okay? We're looking for the probability that he drinks tea and not coffee. So that's represented like so. Tea and not coffee. So where exactly is that in our Venn diagram? If I wanted to make a quick little sketch off here to the side, there's my tea, there's my coffee. So I'm looking for the intersection between tea and not coffee. So that's, the green represents not coffee, the yellow represents tea, and so the intersection will be right in here. That's what I'm looking for. And so then that will be a total of 24 out of 32, okay? Now I know you're probably thinking, this is not conditional probability, this is the regular probability. Well yes, that's very true. A lot of these problems, it's not going to be just solely conditional probability. They might ask you to find regular probability, you know, looking at it as a whole, but then they might ask you further along some conditional probability questions like C and D. C and D are conditional probability because it says if he's a tea drinker, he drinks coffee as well. We're looking for the probability that if he's a tea drinker, he drinks coffee as well. The fact that he's a tea drinker is our conditional probability. That is our given. That's our condition. So if I wanted to write it in correct sense, we're looking for the probability that if he's a tea drinker, so tea is going to go at the end because that's the condition, and then coffee is going to go in front. Okay? So again, whatever the condition is, it goes second in the formula. So then I'm looking for the probability of the intersection between coffee and tea, and I'm going to divide it by the probability of tea. So the intersection between coffee and tea was 12 out of 52. The probability of just drinking tea, of drinking tea is a total of 36 out of 52. And so if we keep, change, flip, we'll see that we'll have 12 out of 36, which is 1/3 if you reduce. Do we have to reduce? No, we don't have to, but we can if we want to. So the probability that if he's a tea drinker, he drinks coffee as well, is 12 out of 36. And the last one, if he's a tea drinker, he does not drink coffee. Here's another conditional probability. This is the condition. So if I wanted to set this one up, and sorry for the arrows and all this space, we would set it up as if he's a tea drinker, that's the condition, so it goes second, he does not drink coffee. So we're looking for the complement of him not drinking coffee. So then we would set it up as the probability of the intersection between not coffee and tea, all over the probability of tea. Again, the condition goes second. And a lot of times with conditional probability, they'll have you find part of the condition somewhere else. Prime example, the numerator for this particular problem, we found the answer in part B. Because the intersection between not coffee and tea was what they asked us in part B. So it's going to be 24 over 32 divided by the probability that they drink tea, which is 36 out of 52. And in this case, well, unfortunately, we're not going to have, oops. I just realized something. Hopefully you guys saw it too. Back up here in part B, it shouldn't have been out of 32, it should have been out of 52. Because there were 24 people that drank tea but not coffee out of the 52 total. I knew something was wrong because, again, those denominators should be the same because they should cancel out. So hopefully that didn't throw you off. I really hope that didn't throw you off. So 24 over 52, keep, change, flip. So the probability that you pick somebody at random, if he is a tea drinker, he does not drink coffee, is 24 out of 36. And that's conditional probability, okay? I hope this wasn't too bad, and I really hope I didn't mess you guys up on this example with this part right here in part B. And I thought about it some more. I think I do want to do this example. I know it says pod. It was going to be your pod on Monday, but that's okay. I'll just come up with a new pod. So I want to make sure you get one more example of conditional probability. It says consider the events A and B, where the probability of A is 2/5, the probability of B complement is 1/4, and the probability of the union between A and B is 7/8. Part A says to write down the probability of B. Well, remember, if we had the complement, all we have to do is 1 minus the complement to find the probability of B, so that's going to be 3/4. That's what we did on Tuesday. Now to find the intersection, we're going to have to use the addition rule which said the probability of A union B is equal to the probability of A plus the probability of B minus the probability of their intersection. And that's what we're looking for. We know the probability of A union B is 7/8. Probability of A is 2/5, and we just found out that the probability of B is 3/4. So to find the probability of the intersection between A and B is just the linear equation which we solve for. Hopefully you did this without your calculator, just like how I did. That's why there was a silence. So 11 over 40 equals the probability of A intersection B, using the addition rule. Now this last one, hopefully you remember what that symbol means. That's right, it means conditional probability. So the formula says that the intersection between A and B, all divided by the probability of B. Remember, whatever second is the condition is what follows the word given, and is what goes at the bottom in our formula. So we plug in. We just found the intersection of A and B is 11 over 40. And the probability of B is 3/4. Now I know it's not the same denominator, but this is one of those situations because it gave us different types of probability and they weren't all associated with each other. So we keep, change, and flip, and simplify, okay? Hopefully you recognize that 4 goes into 40 10 times. So our answer is 11 over 30. So the probability of A given B is 11 over 30. Again, if you have any questions, I'll post a video onto my big campus from YouTube, so you guys can check that out. Take a look at your homework. It is attached to this post. Let me know if you have any questions. I won't see you again until Monday, so let me know if you have any questions.